First of all, it's a reaction search. So I will place in my reaction. And the question, just a reminder, was how can we maybe selectively reduce something in the presence of another reducible group? And you can also maybe change this to maybe protecting groups and so on. So in this instance, we're going to look at a benzyl group. We'll also look at then putting in what the question will be is reducing a nitro group to an amine in the presence of a benzyl group and a halide. So people tend to have difficulties drawing nitro groups. So a few tips for you. On the top right hand side, we have the abbreviated groups here. So you can open this up, you can type in NO2, you can click expand, and you can put that wherever you want on the screen. You can also use this for different protecting groups. For instance, if I was making a PMB group and so on, you can use this again. So it's a nice little shortcut. So you then not have to draw this out each time, especially if you're using, say, something like an FMOC group. What we can do is also the shortcut is just simply type in the canvas. So in this instance, this nitro group is going to reduce to the amine, and we're also going to have a halide in there. So again, just to point you to our generic atom on the right hand side, we can then open this up and use the generic X atom. And this wants to be remaining in the product. Now our benzyl group needs to be attached to something. So in this instance, we are going to go into the periodic table and create what's called an atom list. And we're going to select nitrogen and oxygen and basically say, okay, this is on a nitrogen or an oxygen in our group. But this could be obviously attached to something else. So we're going to open this up for further substitution with the maximum substitution count. So this is basically saying, other than the benzyl, what else could be attached to these two atoms? Because remember, we're keeping this as drawn, and we only want to open up substitution in this position. Now the nitro group obviously needs also to be attached to something, so we can connect this here and also with our halide. So in this instance, if I, as a shortcut, type R on my keypad, I'm going to put an R group in here. So I can go to the select smart R group here, but in terms of speed, this is also useful and also quicker. Now I also need to define R in my molecule. So again, if I come up to the right hand side into my Reaxys generics, I can then use particular R groups, and I can select here either an aryl group, and again the shortcut can be I can also type in heteroaryl on my keypad and put that here. Once I'm happy, I can then go back to R and select this as R. Now just to help the tool, what I might also want to do is tell the system that this nitro group is now this amine in the product. So I can, for instance, use what's called the manual mapping tool here on the left hand side. So I can select this with my mouse, and then with hovering over my atom, I can left click and drag this into my product. So this is basically saying this is now this in the reaction. Now a lot of users do also miss the more options button in here. So just to help the tool with the search, if I click on this, I can also use what's called a fragment search. So I've obviously partially drawn out my reaction, partially drawn my starting materials, partially drawn my products. And what I want to do now is keep these fragments together. So I'm telling the tool these must all be in the same compound. And then what we simply then need to do is transfer to query and click find. So now we can see our search is ran. We've got 897 reactions, and we can view our results. So now we are in the result view. I can hide the conditions here just to show you on the screen what's happening. So hopefully the color is coming across. So in blue, you can see everything that I've specified, and you can also then see this in the product. And what you can see in this instance, that the nitro group here has in fact been reduced to the amine. And then we can go through, and you can see how by using the fragment button and not having to draw everything out, again, in terms of complexity, in terms of products, and you might not also know what's been performed in the literature, it's a handy way of putting in, say, a broad enough query to then, help you along with your search, but more importantly, maybe get to the information which Reaxys is known for. can we get that excerpted experimental data, and this time coming from this Glaxo patent and so on. So that is one of the ways that you could use the fragment options in Reaxys.